In the nearby future, we're going to look at functions which are complex. That is combination of trigonometry and exponents, log and say polynomial expression. So combination of two or more, actually, not even just two or more functions. We're going to see that, and to understand those better, we will make use of something called as composition of functions. So the basic idea of composition of function, other than this, is to help us break down complex functions and understand them better. That's the whole funda. That's the need of it, actually. Now, what is the basic idea? When we are passing one function's output to another, what does that mean? Let me show this. So we have two functions, right? So this is the user input indicated over here on the left hand side. That's the user input. The function processes it and gives us an output. This is where the important thing happens. This output of f of x will be the input of g of x, and the g of x will process that and we get another output. Okay, so the funda is that simple. So let me represent all of this with a box. So that's your function, and this is your another function. So this is f of x, and that's your g of x. So we have the input, processing happens, and that will go as the output of the next function, and we have the output again. So this is our user input, and that's our output, and this will go as an input, and we have the final output. So in some ways we can consider this as the internal. You'll understand why. And that's our external. Again, it's just a word that I'm using. It's not an official terminology over here. Okay. Now, how to represent this? This is represented with G composition of f of x. G composition of f of x. G composition f of x. Okay. So this means G of f of x. So basically we'll pick up f of x, process it, whatever the output we get, we're going to put it in our g of x. That would be your input for g of x. So let me put across an example. It will make a lot of sense. Say I have f of x that is equal to x square and g of x that is equal to 3x plus 1. Now, if I happen to give some input or make it go through some process, how will it look? It will look something like this. So this is our f of x as x square and g of x as 3x plus 1. So we have an input, x square will process it and give us an output, and that will be the new input to g of x, and 3x plus 1 will process it and will give us an output, right? Now what if we have some actual input value? How does it look? Well, I'm giving an input of -1. So x square will give us what? X square will process it and give us, yes, 1. 1 will be the input to g of x, and g of x will process this by placing 1 in place of x. So 3 into 1 plus 1, that is 4. Right? That's what happened over here. So let me put it across for you guys so that you guys can also copy this. So the same line of thinking. Oh, I didn't copy that properly. No. In place of f of x, we have x square, and g of x, we have x square and 3x plus 1, right? So if I give an input of say -1, this will give us an output of 1, and that will be your input. And finally we have the output to be 4. You guys agree? So this representation talks about the processing happening from right to left. So the sequence of processing always has to be considered from right to left in this representation. Okay, so let me give a final example. The final expression of composition of functions. See, we just saw that yes, we have the idea of composition of function, but we need to put it in a mathematical form. See, we already have f of x as x square and g of x as 3x plus 1. So your function composition of function talks about right to left, that is f of x will be the input to your g of x. So in place of f of x, I'm going to put x square, and in place of x over here, I'm going to replace that with x square. So this is x square, and so this will be x square. So the final expression is 3x square plus 1. Let me pick up an example for you guys. Example, g of f of 4, or let me put it in both the manner, g composition of f of 4, which is also g of f of 4. So will give us 3 times of, correct, 4 square plus 1, and 16, 48, 49, right? So let's see this as well. So we have the same expression, no difference. So input, user input, and we have the output. That will be the input for your g of x. That in turn will process and we give us an output. Now we have an input of 4. That is your user input. F of x will process that and give us an output of 4 square, that is 16. 16 is a new input. 3 times of 16 plus 1. The processing will happen, and that would be 49. Right? I hope it made sense. So that entire thing is represented in this form, and that's your final expression. So using this line of thinking, we learn a lot of rules and we learn a lot of concepts. So it's important for you guys to understand this. It's a very simple concept now. Built on this is your complex functions. So that we will understand with the help of composition of function. It's a very simple topic, but the application is complex. That I agree.